Welcome all, this is Saud. We will go through some troubleshooting tips and techniques to locate faults in short time for switch mode power supply. We will take this as example, ATX for computer power supply. In this one, when we apply the power and activate the power on signal by connecting the green wire to ground black wires, the fan is not starting. The other voltages 12 volt, 5 volt, 3.3 volt are dead, but I am getting the 5 volt standby through the violet wire. This indicates that the main rectifier circuit and DC part plus 5 volt standby circuit is normal, and the problem in the switching mode section. Normally, very fast I start by checking status of fuse and do some visual inspection to see if any visible faulty component can be located. The second step, while the circuit in power off, I just check for short circuit in all these big semiconductor components. They draw a lot of current and more suspected to go short. That include all the transistors and diodes. To check also for short across all the electrolytic capacitors, and all this by using multimeter. Once you locate the shorted component, replace it, but keep in mind to check that the short may be caused another failure in the circuit, which is connected in the same loop. In this circuit, I checked and I could not find any shorted part. Therefore, at this step, I will need to continue the troubleshooting while the power is on. Now, here is very important advice. We need to troubleshoot this circuit sometime while the power is applied, therefore exposed to high voltage. It is not advisable to do this unless you are qualified and fully understand what you are doing to avoid harm to human and equipment. It is also strongly recommended to power up this through isolation transformer during the troubleshooting. Before we go ahead, I will give brief explanation of the circuit. Here the AC power is connected, and through the fuse it goes to the main rectifying diodes. The DC is filtered and smoothed by these two big electrolytic capacitors. The 5 volt standby is generated by this IC, which is switching this transformer. Some other design they use transistor in this place. Anyway, the 5 volt standby, it has low power requirement. The output from the transformer is rectified by this diode and smoothed by these capacitors. Then we get the 5 volt through the violet wire. These two transistors, they are the main switching transistors. They receive the pulse width modulation signal from the controller IC. This IC will keep monitoring the load and other parameters and generates pulse width modulation signal with varying duty cycle in accordance to the load. This in order to fix the voltage. This signal will be coupled to the transistor through this middle transformer. The transistors will switch the big transformer, which is having 3 outputs windings. The first one generates the 12 volt part, which is rectified by the common cathode rectifier, and then the output through the coil will be smoothed by the electrolytic capacitors, and here we get the final 12 volt DC through the yellow cable. The same applied for 5 volt, then coming to the red wires, and the 3.3 volt to orange wires. Try to recall the location of components, as during the test I'll put the board upside down, and I will use the picture of the top side to show. The power is applied, and here we get the DC supply normal after rectification and smoothing, and it is reaching to the collector of switching transistor. I have checked these 2 transistors during power off. They are okay. So next step, to check if pulse width modulation switching signal is available at the base. This signal is coming from the controller IC through this transformer to the base of the transistors. No signal at all. This signal can be missing because of 2 reasons here. Either the signal is not coming from the secondary side, or some of associated components connected to the base is faulty. I have checked these components, few resistors and capacitors during power off. They looks okay. No any short or open circuit, at least. Therefore, the conclusion is there is no pulse width modulation signal from controller IC side. I have shifted the oscilloscope ground connection to the secondary side. As you know, in switch mode power supply, the primary ground is isolated from the secondary ground. No signal also at this side of the transformer. Now we can start assuming something wrong with the controller IC circuit. So we can start from there, coming down to the transformer. One important tip here. Yes, we might not be having the schematic diagram for the board, but still we can use the datasheet and pinout of the IC as helpful tool. Another tip, this type of boards is single layer PCB, so it is very easy to trace the circuit from one side compared to multi-layer boards where it is very difficult to do that. Therefore, after we manage to solve the problem, I will make simplified drawing for the board by tracing the circuit. The purpose of that is to explain the expected signal shapes later. First, we check if the power supply is getting to the IC. This is coming from the 5 volt standby, which we found it was normal. Yes, the power is okay as clear. If you remember, we need to activate this power supply by shorting the green wire to ground. That is connected to the power supply on pin of this IC. This pin is normally pulled up to 5 volt, and when we short the wire, this going to 0. Good, then the power on command is okay. We will check now the output of this IC, which is going to drive the transformer. There is 2 outputs connected to 2 transistors, and then going to the transformer windings. This is really interesting. I am getting the pulse width modulation signals here, but as you can see, it is not continuous. Keeps oscillating on and off, and I think I can explain that. In this type of power supply, when we have overcurrent or overvolt, undervolt at output voltage stage, this effect is happening. So the IC is getting shut down by this and then restart, and it just keeps doing this. And I can guess this is happening now because of undervoltage at the output, because we found the main switching transistors are off and no any voltage is generated at the other side. And I don't expect overcurrent condition because of mainly 2 reasons. First one, I have already checked the components at the output voltage side before during power off for short circuit, and none is short circuit. The second reason, again, to get any current at secondary side, the main switching transistors need to activate at least, even oscillating or on and off signal. But as we checked before, no any signal is reaching there at all. So my conclusion, this signal output from this IC is not reaching to the middle transformer. So let's trace this part. I will switch off the AC to check this. The signal from the AC is going to 2 transistors. I expect NPN type. Let's check. The base is of course connected to the output pins of the IC. Base to collector, base to emitter. So yes, it is NPN, and this one is okay, as you can see. Let's check the other one. Yes, also okay. The emitter is connected to ground through 2 diodes. Let's check the diodes on circuit. Both good as well. The collector side from both transistors is connected all the way to the transformer windings, nothing in between. The middle pin of the transformer, I believe it is the one providing the supply voltage to both sides of windings, which are connected to the transistors for switching. I think we are getting closer. The pin is getting the supply from one of the windings of the 5 volt standby transformer. So let's switch on AC power again and check the signal at the collector side of the transistors, plus the supply voltage here. No signal at collector side, but we have good signal at the base. while we already checked both transistors are okay and the voltage is low here. Now this means the supply voltage through the windings is not available. Yes, the supply voltage is available here but not reaching to the transistors. And I have noticed very important finding here. It must be the cause of the problem. If you can notice, we really have dry or cold solder at the middle pin, so it is not connected. See, the voltage is reaching the PCB track but not appearing on the pin. I will clean the pins and resolder them back and we will see the results. I resolder the pins, and before powering up, here brief explanation of the problem we have. The second winding of 5 volt standby transformer is supplying the voltage to the middle pin of this transformer, and through both side windings it goes to the collector of transistors. So this one was dry solder. That's why the supply was not reaching the collector of both transistors. The signal was there at the base, but no switching is happening. I will start the power supply now. Yes, as you can see, it is powering on now. We have the 12 volt, 5 volt is okay, and 3.3 volt is normal. Another important tip here: using the right test equipment is very helpful to check some type of failure modes. Just think, if I didn't use the oscilloscope at this particular fault and just used the multimeter alone, guess how long I could have taken to find this issue. Especially, we don't have the drawing to know the right voltages at transistor pins. What most helped me here, when I saw the pulse width modulation signal coming from the controller IC, and that helped me taking rest of conclusions. I always say the oscilloscope is giving some sort of 3-dimension approach in troubleshooting comparing to multimeter alone, which may give 2-dimension only. But at the end, you can make the best out of whatever test equipment available with you. The last step, now I will try to trace the circuit to make simplified drawing for main components on the board. The idea is not to study the full circuit, but to understand the principles, and this understanding will be very helpful for fault finding. Very fast. Here we have the mains coming rectified and smoothed by these two capacitors. They provide the main DC to the switching transistors and to the 5 volt standby as well. The 5 volt standby controller, this IC is switching the DC by using internal built-in transistors through the transformer to generate the 5 volt standby at the other side. with the required feedback circuit. These are the switching transistors working in alternate way. When one is on, the other is off, to generate changing polarity voltage at primary windings. When top one is on, it will connect the transformer to plus, then it will go off, and then second one will be on, which will connect the transformer to ground. And we will see the shape of this signal in a moment. Then the three main voltages are generated, rectified through the common cathode rectifier, and get filtered and smoothed here. Here is the controller IC. In this design, it monitors the voltage of 3.3 volt for regulation and correction. There is other inputs related to undervolt, overvolt, overcurrent protection. I didn't include here. Also, the pulse width modulation error amplifier input driven from 12 volt and 5 volt, not shown for simplicity. The pulse width modulation output from this IC is going to 2 MPN transistors, then to the middle transformer, and then driving the switching transistors. Last, let's check few waveforms, and then we are done with this. I have connected few loads on the voltage output. This is the signal at the base of the two main switching transistors. So as you can see, when one is on, the second one is off, and when the second one becomes on, the first one is off, and there is some time delay in between to avoid both comes on at same time. Now let's see the signal at the secondary side. This is input to both sides of the common cathode fast recovery diodes, and at output side it just do the rectification and brings the negative cycles to positive side, and we get both combined wave. And this is the input to the coil. Then this will get filtered and smoothed, and we get straight line DC voltage. We will see now the effect of increasing the load current on the pulse width modulation signals. So now I'll try to draw more current by increasing the load here. As I increase the load, the width of the waves increases as well, directly proportional to the load. And that's how the controller IC regulate and fix the voltage with varying output current. I hope this was useful, and all the best.